Hello everyone, I'm Ashok. Welcome to another video on machine learning and data science terminology series. In this video, we look at PCA. What is PCA? PCA stands for Principal Component Analysis, and is one of the techniques we use in machine learning for dimensionality reduction. What PCA does, it converts your dimensions into principal components. And by doing so, we could actually reduce the dimensions because most of the variance are captured in the first few principal components. So what I mean by that, let's say you have a data like this. Okay, there's some data like this, and this is your x1, for example, and say x2, two of your dimensions. Okay. So I want to reduce the dimension. So if I drop x1 or x2, we lose significant data because see all of this variance being captured here. See all of this variance being captured here is being lost. All of the data we have, every point has some value in x1 axis, x2 axis, and also has a values in x1 axis. All of these are lost. So we lose a significant variance, significant information hidden in the data. What principal component analysis does, it actually rotates the axis, it moves the axis in such a way that it reduces the variance in one axis, principal component axis, and increases the other one. So let's say I'll take a different color for this. So let me say you have this axis, but this time I'm going to call these axes as the new axes, which is principal component 1, and this is principal component 2. And then I'm going to simply rotate them and reposition it in such a way, for example, like this. Okay. So what I just done now is you can literally see that the variance is being all captured in your PC1, which is principal component 1, and PC2 actually have almost very less variance. So you can only see that it's a very small variance. So there is no much information being captured in PC2. All of your information is variance is being actually captured in PC1. If I take only PC1 for my analysis and drop PC2, PC2 can be dropped. This is good enough because approximately, as I can say, 90 plus 90 95 plus data variance is being captured in PC1, and this is what the principal component analysis is. So it basically converts your dimensions or axes into a principal components, all right, and thereby uh, and while doing it, it ensures that larger variance, all the variance, most of the variance are captured in the first few principal components. Thereby, you can simply drop the further principal components, which reduces the dimensionality. So, simply the goal here is to reduce dimensions. Reduce dimensions. Okay. In this case, two variables has become one variable. But in general, when you use principal component analysis, there are quite number of variables, features, for example, or dimensions. Let's say you have 25 dimensions. By using principal component analysis, you could probably reduce it to 4 or 5 dimensions. Okay. If you want to write principal components as the original axes, this is how it looks. PC1 is theta 11 x1 plus theta 1 to x2. Theta 1 1 and theta 2 2 are constant, which are fine tuned. This is theta 2 1 x1 plus this is theta 2 2 x2. So I'm taking a linear combination of the original axes and converting them into a different axis, which we call it as principal axis, principal components. The values of this theta are fine tuned in such a way that we get maximum variance captured in the first few principal components. Okay. So that's principal component analysis. If you look at the 3D, and this you can find it in setosa.io, I shall leave that in the description. The 3D modeling of it. So we have some data, as you can see, and the data is in all, the variance is in all the axes. Okay. So you can also see that the data is distributed, the variance in x-axis like this, and all are between like 0 to 5. So random values being taken. You see that the values are actually in 0 to 5, slightly more than 5 and slightly less than 0 as well. And kind of like same variance. But when I say show PCA, you can see that literally the axis is turned, and now in the PCA, PC1 captures from -5 to +5, and all the rest of the two principal components have lesser variance being captured around the 0. All right. So if I take only PC1, it predominantly captures all of the information, about 90, maybe 90, 92% of your variance is captured in principal component. You can reset it. I can show it again. So you can see that the axis is being turned. You can see this here. Been turned in such a way that it's trying to capture majority of the data in your red color axis, which is this one. Reset, and red is like this, and now red is aligned to the axis where you have a majority of the variance is being formed. Okay, that's your principal component. Hope it is clear. I have another video which talks PCA and implementation in Python in more detail. But from a terminology perspective, PCA, principal component analysis in machine learning, is used as a dimensionality reduction technique. And this is done by converting the original dimensions or axes to a principal components. Okay. Thank you very much for watching this video. If you like this channel, please subscribe, and I'll see you in the next video.